Alright, today, lesson 8.6. Should have this open up on your OneNote. Today, we are doing an extension. We're relating geometric sequences to exponential functions. So, I did the warm-up because I'd rather us just get right into the work. So if you want to see how we did that, you can go to it. But I can identify, write, and graph geometric sequences. Alright, first thing. Gentlemen, a couple of you are still talking. I need you to focus so you have something new today. It says, arithmetic sequence. A numerical pattern that increases or decreases at a constant rate is called the common difference. The equation. Another equation for us to kind of learn. And at first, it looks like a lot, but it's not too bad. It says a to the n equals a1 plus n minus 1 times d. Now, the important part to this is that a1 is your first term, d is your difference, and then n just stands for whatever common term you're asking for. So you'll see the examples. They said 3, 5, 7, 9. This is part of an arithmetic sequence. And the reason is the pattern is just they're adding 2. Every time it's increasing or decreasing at a common rate of just 0.2 or plus 2. Now, I did some work on the side just to show you how you would solve this, just to prove it. So, this is what I do all the time. This is a good little habit. If you ever think you have a function correct or you think you identified it right, use what they've given you to check yourself. So like, I see there's 4 numbers in this pattern, so I'm going to check the 4th number. My answer should be 9 when I do this. So when I do this and I write out the equation, a to the nth means a to what term am I looking to? So I'm going to the 4th term. So I said a to the 4th. I'm trying to find out what the 4th term in our pattern would be. You take your first term in the pattern, which was 3, and I'm going to add it to n. What number am I going to? I'm going to the 4th term, so I put 4 in, and I do 4 minus 1, and I times it by what our difference was. So when I do this, I have 3 plus 4 minus 1 in parentheses times 2. Well, 4 minus 1 was 3. So now I have 3 plus 3 times 2. 3 times 2 is 6. So 3 plus 6, I got 9. Is the 4th term 9? Yes. So this is how I can just check myself. It looks like a lot, but it's not. It's mainly this front thing, the a to the nth power. You're really not doing anything with it. It's just, hey, your answer for whatever term you want, you have to do your first term plus your term that you want minus 1 times the rate. So we'll do a couple examples with that. We'll come back to this. Your geometric sequence. It's a sequence in which each term after the first is found by multiplying the term by a constant r called the common ratio. Its equation, a to the n, so it's exactly the same as the other one. You're saying my term I'm trying to solve is my first term, a to the 1, times my ratio, but the ratio is, the exponent is the term minus 1. So, once again, I'll show this to you. They say 3, 6, 12, 24. Obviously, our pattern is times it by 2. 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. And so you might say, why do I even need to know this expression? Because then I'll just go, okay, 48, 96, 100 something. The reason is because what if I want to know what the 23rd number is? You're not going to want to double and multiply that far off. So, once again, this is my example to show you how you use the function. I really recommend this, like, for you guys in the future, not just for this, but for any math you do. If you have an equation and you're ever trying to learn the rule or how the equation works, start with small numbers and start with answers that you know. So for like this example, I know the fourth term is 24. So instead of me trying to learn this and say, let's go to the 50th term, well, I don't know if my answer is right or wrong. I know for sure the fourth term is 24, but I'm going to pretend I didn't know. So I used my equation. I'm going to say a to the fourth term. I want to know what the fourth term is. Equals, so how to find it is I take my first term, that was 3, and I'm going to multiply it by the rate. I see the pattern right now as timesing by 2. So 3 times 2, but I have to put that rate as an exponent, and I say n minus 1. Well, n is what term I'm going to. I'm going to my fourth term. So I do 4 minus 1, which would be 3. So I'd have 3 times 2 to the third power. 2 to the third power equals 8. So I'd have 3 times 8. 3 times 8 is 24. So the fourth term should be 24. And I see that it is. Okay. I would write this down if I was you, copying kind of what I have, because when you do your homework today, if you need to go back and kind of make that connection, that's a great thing. Like I said, today's actually pretty easy, I feel. So, here's the first thing. Don't shout the answer. I want everyone to kind of know their answer, and they can write down what they think. Determine whether each sequence is arithmetic or geometric. Then write the next term of the sequence. Okay, so for A, it goes 3, 6, 9, 12, 15. Don't shout it out, but decide, is this arithmetic or geometric? Remember, if it's arithmetic, your difference is pretty much adding or subtracting. If it's going to be our geometric, we're going to be multiplying or dividing. So go ahead and do A and B, right? If you think A is arithmetic or geometric, and write if B is arithmetic or geometric, and then find out what is the next sequence. All right, what'd you get on A? Which one is it? Alex, what is it?
It's arithmetic.
All right, it is. We know it is because the pattern here is between 3 and 6 is either adding 3 or timesing 2. But between 6 and 9, that's adding 3. 9 to 12 is adding 3. Now, technically, they asked me the question, what's the next term in the sequence? So it would be what? 18. Did you have to do the whole equation? No. They just said the next term. We might come back. I'm going to see how much time we have when we get to the end. I might come back to this and ask you to do like a 15th term just for fun.
What?
Fun. It's fun. That's fun. It's fun.
Fine.
It's also
All right, so B. Is B arithmetic or geometric? Huge hint. We're doing like we're trying to learn. So if I'm going to show you one of both, we only have 2 questions.
Geometric.
Yes. Geometric. What is the rate then? From Rowan. What would be the rate, buddy? On this B, what would be my rate? No. How do I get from 128 to 64?
Oh, cut it half.
So I could either say I'm multiplying by half or I'm dividing by 2. And instead of saying divided by 2, I probably use multiplying by a half. Alright, so multiplying by 2. What would be the next number in our sequence? Yeah? Huh?
I can't see my eyes.
You can't what?
I can't see my eyes.
Oh, that's okay. I can't see double T's.
You can't see R.
I can't say double T's well. Like, if button on your shirt, I have to think about it. Otherwise, I say button.
Stop.
So, we'll talk about later about my weird speech. Alright, so graph the sequence. So now we're being asked to graph this. To do so, a lot of our graphing comes off of tables. You have X and Y. So really, to tell you the truth, the way you look at this, the easiest way to graph a sequence is, here's our sequence. And when they ask you to graph it, a lot of people get confused on how to do that, but it's pretty simple. 48 was my first term. So when we make a table, we just make X be the term. 1, 2, 3, 4, 5. And I say my first term was 48. My second term was 24. My third term was 12. Fourth term was 6. What would be my next term? Let's do a fifth one just for fun. 3. Is this arithmetic or geometric? What's the rate? Dividing by 2 or multiplying by 1/2. Alright, now, here's, oh I did. I was like, I thought I did this last night. On mine, I already went through and numbered my grid for you. I know yours isn't, but I went through and did it because I looked at this. I decided to make my scale 2. So, when I graph this, I'm just going to go do my points. Can I put 0.1 in there? No, I don't have enough on my scale, so it's okay. But I'll do 2 and 24. So here's 0, 1, 2. 24 is up here. 3 and 12. 4 and 6. And 5 and 3. What does this look like now? Is this a linear line?
No.
So is this exponential growth or exponential decay?
Decay.
Very good. Left to right, we are getting smaller. So what would be my domain? Good. My domain, my x terms up here. I could do any real numbers. I could ask you what is the sequence for the 5,000th term. So I can do any real number. What about my range?
Y is greater than 0.
Y is greater than 0. Now, you said, no, that's a great question. You said y is less than 48 because we started with 48, right?
Yes.
What if I asked you what was the 0 term? Or the negative 1?
96.
Or the negative 2?
Lucas, calm down.
It'd go the opposite. So right now when we are dividing by 2, it'd get bigger. And so it'd go up even higher. Okay? We could write an equation out of this. But it's kind of funny. I know it doesn't ask you to.
I don't know how. I get what you graphed, but I don't know how to like make an equation. So you can do that.
So let's do the equation.
Let's do it.
So let's try the equation real quick. First, we know the equation is going to be y equals. Now the first part we have to know.
Is it a
Metric.
Yeah, it's that. Okay,
Yep.
because it divides by 3.
Yep. Because geometric, we're either multiplying or dividing for our rate. Okay. When we do this, and we're finding our decay, we first have to identify what is A. So what would A be?
A would be, no, it would be 96.
Good. How'd you get 96?
Because it's 48 times 2 and it would be getting bigger.
Good. So we would have 96. What's next in our equation?
The times 1.
Timesing a half. We've identified that already. Our pattern, our rate, gentlemen, make sure you're following so you can do this. Our rate for the geometric pattern was divide by 2, or we said multiply by a half. So times
1/2, and then we have an exponent of x. That is our equation. So if I ever asked you what is the 12th term, all you would do is change your exponent to 12. That'd be big.
That's 1 year younger than I am.
Okay, write the, what did I do? Oh, write the rule. Write the rule for the geometric sequence, then find a to the 10th term. So I already wrote out the equation. Guys, follow along. See if we can do this today. I already wrote out the equation that we need. That is for geometric sequence. For geometric sequence, remember it's a to the nth term equals a to the first term, whatever your first term is, times your 8 with the exponent of the term minus 1. So it's a lot there. Here's our geometric sequence. 2, -6, 18, -54, 162. So, first thing we have to do is identify what is our common ratio. What are we going up or down by? Well, first I'm going to notice my sequence. The numbers are actually getting bigger or smaller. So I know I'm going to look for my easy multiplication. It's not going to be a fraction, it's going to be a whole number. It also goes positive, negative, which means it's a negative number. That'd be my highlighter. So what number are we multiplying by? So, first thing, write the rule. The rule is going to follow this part. I'm going to copy this. My rule is a to the nth power. Remember, nth power means when I'm solving this, whenever I ask you what term, n means what term I want to go to, equals whatever my first term, actually, I don't have to write a to the first term because what is my first term? So 2 times r, well, we know what my rate is. My rate is -3, but it has to be the exponent of n minus 1. So if I ask you on your homework, and you had this information, write the equation, you do not write this for your answer. That is the equation for geometric sequence. For this problem, this is your answer. A to the nth term equals your first term times your ratio, and then the exponent n minus 1. Now they ask us to solve for the 10th term. So I substitute the 10 in for everything. I want to know a to the 10th is 2 times -3, and we're asking for the 10th term, minus 1. I'm going to pause my video real quick. I want you guys to go through and solve the rest of this equation. Okay, looking at this one, Daddy, what's the first step from here, buddy? I have a to the 10th term equals 2 times -3 to the 10 minus 1 power. What would you do first?
10 minus 1.
Thank you. So let's do this. I'd say 2 times -3 to the 9th power. Lucas, what are we doing next? Or John, what are we doing next?
Doing -3 to the 9th power.
Alright, so I'm going to go to my calculator. 3 to the negative to the 9th power is -19,683.
That's what I got.
19.
My calculator works.
Okay, Grace, what do we do next?
Then we multiply those two together.
Okay, Your final answer should have been negative 39,366. Okay.
Oh wait, it's not super cheap. That's too much small. Never mind.
Homework. Pay attention, I want to go over this and one other big thing. So, working with these patterns, make sure you can go back into your notes and understand these two equations. Learning how to write them, it is something in math that we probably have to memorize. Then, your homework, due by Tuesday. Gentlemen, listen to this because this is your next week. Next week, when you guys come back, Tuesday, we will grade this and we will be doing a review over this chapter. You will be testing over this chapter on Wednesday and Thursday. It's a 2-day test. On Friday, we will start a mini unit, and it's not very big. Okay? Your homework, extension 8.6, page 541 through 10. All